All right, so in this session, we'll see what is the hypothesis testing. So hypothesis testing is one of the most important things if you wanted to become a data analyst or a data scientist, and it is a really important thing in a probability. Now for the hypothesis testing, what is the hypothesis testing? So first, you define, there are 4 steps to do a hypothesis testing, right? So the number one, so we're gonna understand all of these 4 steps with the help of an example. I know if I just tell you this is the null hypothesis, alternative hypothesis, experiment and reject, so you won't be able to understand it until and unless I make you understand with the help of an example. So let's just start it with an example. Let's say we need to find out whether the coin is fair or unfair, right? So if you have a coin for toss, then you need to find out whether that coin is fair or unfair, right? Uh, if I just only say, that we need to find out whether the coin is fair, right? If I just only say whether the coin is fair, let's just ignore the unfair thing. Firstly, we need to find out whether the coin is fair. If I say like we have a coin, in terms of a coin, we have the 2 outcomes. Mainly, either it will be a tail or a head. So these two we have are total outcome, right? So these two are the outcomes of a coin, right? So we need to find out that whether the coin is fair or not. If I just say you that what would be the probability to find out whether the coin is fair? Let's say I just find out the probability of head, right? So if I toss a coin 100 times and if I get 50 times head, right? If I get the head 50 times, which means that our probability is 0.5 or a 50%, then we can easily claim that the coin is fair, right? So our null hypothesis, this is basically your null hypothesis, right? The question that says that the coin is fair is your null hypothesis, right? So first of all, we need to define what is the null hypothesis. So null hypothesis we have is that coin is fair, right? So this is our null hypothesis and we need to prove it. So whatever the null hypothesis, whatever the thing that is given to you in your question is your basically null hypothesis that you need to prove, right? You have to prove that null hypothesis. Now, what is the alternate hypothesis, right? Alternate hypothesis is the reverse or the inverse of the null hypothesis. If your null hypothesis says that coin is fair, then automatically you can say that your alternative hypothesis is that coin is unfair. If I say that null hypothesis is coin is fair and alternative hypothesis would be coin is unfair, then we would do an experiment, right? And how we gonna do this experiment here? 50%. If I toss the coin 100 times and if I get head 50%, then we can say that the coin is fair. But what if I toss the coin 100 times and out of 100 I got 70 times or 0.7 probability, or maybe say 70% I got head? Now what you will say? Can you say that the coin is unfair? Can you say the coin is unfair? How are you going to say this? I mean, who are you to say this? I mean, you are not a domain expert or something like that. So you can't say directly that if I got the head 70%, oh, okay, so the coin is unfair, right? So for this, we need to just do a experiment, right? We need to do a proper experiment in order to decide whether the coin is fair or unfair. So there are many kind of experiments. There is a Z test or a T test. I will just tell you in your later video about the Z test and T test. But for now, I'm just gonna explain it with an example here. So if I toss a coin 100 times, right, and I say that we need to find out whether the coin is fair, right? So our null hypothesis, what is our null hypothesis? Is coin is fair, right? So if I just toss the coin 100 times, right? So let's say our mean is 50. Our mean is 50. And these are the standard deviation. Our standard deviation is 10, right? So our mean here, which is 50, and our standard deviation, or you can also write it like a row, is your 10. So you can see this is your 50, 60, 70, 80, 20, 30, 40, right? Okay. Now if I say again, if I toss the coin 100 times and I got 70 times, right? I got like 70 times. Let's just say I got 70 times. 70 times I got head. Can you directly say that the coin is unfair? No, you can't directly say. Here, then how are you going to say this? So you need to set some boundaries, right? You need to set some sort of boundaries. And how are you going to set some boundaries? For that, here is another small concept which comes in here is the significance value. So significance value. What is the significance value? Usually the significance value we have is the alpha is equals to 0.05, right? Now, how this 0.05, or you can say if I just put it in a percentage, so it will be like 5%, right? Now, who decide this significance value? Basically, the significance value is decided by domain experts, right? Who decide this is domain expert. So it will be any kind of domain. If we talk about like in terms of the experts who are making these coins, they say okay, so you have the significance value of 5. Now what is this significance value? Significance value basically says that you have this confidence interval right here, right? So if I have the significance value 5, which means I wanted to draw some boundaries here. Let's say I got this confidence interval and I got this confidence interval right here, right? So this would be of 2.5 and this would be again of like 2.5, right? So these two would be your 2.5%, and again this would also be your 2.5%. And if I just minus this, so it would be like 100% minus 5% is equals to 95%, right? This would be your 95% of the total distribution here. Now, when you said this, now you can easily decide whether the observation you get is able to prove your null hypothesis or not. What is the confidence interval, or this interval right here, 2.5 and 2.5, is basically the interval in which we reject the null hypothesis, right? So it means that if your value lies in this region or in this region, then we can say that your null hypothesis is not true and we accept the alternate hypothesis, right? Now, in this case, I said like, okay, I got the 70%, right? So you can say that 70 times you got head. Then you can easily say, okay, I accept my null hypothesis, which is that the coin is fair. And I would say that, okay, coin is fair, right? Because I got the 70%. So I can say like, okay, coin is fair. Now what if I say that I toss the coin 100 times and I got the p value here, or the probability here is, which is 80, right? Probability I got 80. Now you can see that 80 is lying in this interval. Then you can say in this outer interval, we can say that 80 is lying here. So your value is lying here. Then you can say, okay, your null hypothesis is rejected. Your null hypothesis is rejected, and we will say that the coin is unfair, right? Coin is unfair, right? So because you got the value which is out of your confidence interval, right? So because this interval, this if your value exists only this interval, your null hypothesis is accepted, right? So this is the main thing. So these are the 4 steps. So first what we did is that we set our null hypothesis, which is already present in our question. Then we say alternate hypothesis, which is the opposite of your null hypothesis. And we did the experiment. We just tossed the coin 100 times, we got some result, and we put it on this region, right? And then we decided whether it is rejected or accept or null hypothesis. So again, if you want to say why it is 0.05, it can be changed. Yes, it can be changed. You say like if it is a 10%, right? You can say like if it is a 10%, it is a value. Let's say your alpha value, if your alpha value is equals to, let's say 0.10 or a 10%. So you can easily subtract it from the 100. 100 minus 10 is equals to 90%. So your overall interval will contain the 90% of this and in the 10% here. So if I just redraw this whole thing, if I try to redraw this whole thing here, Let me just remove this. I got the 90% because we have the 10%, so I just divide this 10% here. So it would be like the 5% region this here, and the 5% would be here. And what it will be? It will be 90%. So if I again, let's say if I just remove this thing, let's say now your distribution is like in here, right? Let's say till here. So if I say that if I got like, let's say probability, if I just toss the coin 100 times and I got the p-value of let's say 0.25, right? Let's say I got the p-value here is 0.25, right? So the 0.25 value, this 0.25 value lies in this region, right? So 0.25 value lies in this region. So we say that okay, it is lies outside the region, then it is in this region. This is a critical region. Then we can say that we reject our null hypothesis and we will say that okay, the coin is unfair. We accept the alternate hypothesis and we say that the our null hypothesis is rejected and we accept our alternate hypothesis and we say that the coin is unfair, right? So this is how your hypothesis testing is done here, and I hope you understand this whole concept of the hypothesis testing.